we are going to shoot a video about Hasse diagram. Before explaining Hasse diagram, we are first going to look into partial ordering. So, a relation R on the set A is called partial ordering or partial order, provided if it is reflexive, antisymmetric, and transitive. The set A together with the partial ordering R is called the partial ordered set or pole set. The pole set is denoted by SR. Before that, we need to explain what is reflexive. If a digraph or a set is said to be reflexive, all elements in the set must be mapped onto themselves. For example, 1, 1, 2, 2, 3, 3, 4, 4. If one of the elements are in the set, but let's say that is 5, 3, but it does not map onto itself, it means that this set is not reflexive. Okay, then we go to the next part, which is transitive. A set is said to be transitive if we have 1, 2, and we have 2, 3. The set must have 1, 3. Because if 1 is related to 2, then 2 is related to 3. Therefore, 1 is also related to 3. Okay, let's come to the last part, which is the more confusing part. For antisymmetry, a set is said to be antisymmetric if there's only 1, 2, and 1, 3. It means that it does not have any arrows pointing back. The very important thing is, antisymmetry doesn't mean that it is non-symmetric. Because for non-symmetry, like this case, a symmetry graph is like this. It's equal and it's equal. But for a non-symmetry case, the diagram could be like this. It has 2 on one side, but there is only 1 at one side. But this is not considered as antisymmetry. Because for antisymmetry, the diagram or the relation must only have 1 edges. It means that it could not have parallel edges. If it has more than 1 or at least 1 parallel edges, then it is not antisymmetric. So this concludes my part.
Now that my fellow teacher has explained what a partial ordered set is, the pole set, we'll now proceed and talk about the Hasse diagram. Going through the definition, a Hasse diagram is a graphical representation of the relation of elements of a pole set, a partial ordered set, with an implied upward orientation. A point is drawn for each element of the pole set and joined with a line segment. To draw a Hasse diagram, the provided set must be a pole set. Basically, what this means is that the Hasse diagram is basically just a graphical representation of the elements here that are elements of that puzzle, of course, with an implied upward orientation. Upward orientation just means that you're going from bottom to top. A point is drawn for each element. Each element will draw a point for each element of the puzzle of the partial ordered set. And these elements are joined by a line segment, just like that. The condition to do these steps shown above is the provided set must be a pole set, must be a partial ordered set.
After my friend has explained Hasse diagrams and what they are, I'm going to show you guys an example on how to solve them. And to solve the Hasse diagram, to construct a Hasse diagram, there are certain steps that you need to follow. The first is you have to remove all the loops, remove the transitive properties, delete all the arrows. So as we can see here, we're given a question and we're supposed to construct a Hasse diagram for these points 1, 2, 3, 4, 6, 8, 12. So you can see that in this diagram, it's a pole set with reflexive properties, transitive properties, and is antisymmetric. So the first step, what we do is we remove all the loops, as stated over here. So once these loops are removed, we need to remove the transitive properties. They are here, here, and we just need to delete them and basically construct a graph without them, which is right here. You would have to delete all the arrows, obviously, and they would still be pointing upwards. And after that, you'd be done. This would be your final answer, and that's all.